Welcome to Mossy Rock Games. In this video, I decided to make a game about a dude with a jetpack trying to escape from a volcano explosion, while the lava threatens to swallow him up from behind. I knew that I wanted a flowy, fast, movement-based jetpack game. And in fact, the whole game should be centered around boosting through the map on a jetpack. It should be stressful, it should be exciting, and most of all, it should be fun. But before all that, we have to start from the beginning. I did the ambitious thing, and I opened up a new Unity project right away. The first thing that I did is add a box. This will act as our player until we decide to tackle the game graphics later on. The first thing I wanted to work on was movement. There's a lot of ways to do this, but the most simple way to program movement is just to change the player's position over time. But let's be honest, unless you're making an arcade game, this isn't going to work. I decided to use a more modern approach that I usually use for my platformers. Instead of altering the position of the player, we can alter its velocity. That way, it doesn't break our physics system. So now it works with physics. We can smash into things and we can move around. But it definitely doesn't feel good. In fact, it feels really, really rigid. To fix that, let's make things a little bit more complicated. Instead of setting a new velocity when the player presses a key, let's set a target velocity and then slowly move towards it. Then, when the player lets go of all the keys, the new target velocity becomes 0, and we just decelerate towards that. Let's give it a try. There. That feels a lot better. So now the thing is, we want the player to be flying across the map. At the moment, flying isn't so exciting. In fact, you're barely moving. The thing is, we want the player to be able to turn their jetpack on and off, so we'll use our existing system, and when the player presses space, we'll increase the target speed by ×4. The last thing to do in order to finalize the system is to rotate the player towards the direction of their velocity, which we can do with just a little bit of math. We have our foundation now, so it's time to start making the movement look good. To make it feel like you were really pushing yourself forward, I decided to make the player spew out a bunch of particles behind them when you fly. I used a particle system and just tweaked around a bunch of values until it looked somewhat like fire. We might have to do some tweaking later, but for now, movement looks pretty decent. We'll keep the graphics simple, but we'll add in a little bit of post-processing just to spice things up. The next thing we have to do is make a little test level. First, let's make a rotating beam, something to slow the player down or mess with their timing. I played through the test level a few different times and everything felt good until this happened. As you can see, when these rotating blocks go too quickly, the player will sometimes go straight through them. The issue, well, one of the issues, is that it's unpredictable. Sometimes the player will be flung off into the distance, and other times, most of the time, the player will just phase through. The problem is actually very simple. You see, to make these rotating blocks, we use a concept called parenting, where the two rotating blocks are actually attached to an invisible block, which is what they pivot around. Unity treats this system sort of like a person standing on a planet. Even if that person is standing still on their planet, the planet is still rotating, so the player is moving in a circle, even if from their perspective they're not actually moving. What we're doing is the same thing. We're rotating the planet. And the issue with that is we're directly changing the position of the block. The same way physics didn't work super well when we changed the position of the player. So the solution is the same. Instead of moving the position of the blocks, we have to change its velocity. In short, I had to rewrite the code just using basic trigonometry to move the position. There. Using a sine function and a cosine function over time, the blocks now move purely by controlling their velocity. We used a little bit of math to make the physics work better, and now the player doesn't phase through when they get knocked into. In fact, they do quite the opposite. The last problem is that I can play around on this little level forever. That sounds great in theory, but we need something to encourage the player to keep going. That way, it feels more exciting and stressful, and less like a calming simulator game. So let's add in some makeshift lava. We can tackle the graphics in the next video and make it look scary, but for now, we'll keep it super rough. We can move the lava forward at a constant rate, and make it so that if the player ever touches the lava, they die. Nice. So now we have player movement, a prototype level, and a few well-placed obstacles to give the player a hard time. In the next video, we can start making the levels more interesting, and adding bounce physics. Right now, it feels like a real game, but when we go in and we add the graphics, it'll start to look like a real game. Thanks for watching. I will see you all in the next video very soon.